to do the second product, which will be the real thing they want to do, like the small form factor. But if they try to do that from the get-go, probably going to struggle a lot because they don't even know how to do the big one. Third example, this is was somewhat impressive 5 years ago. A robot doing its own mapping and its own navigation. Did a, that was the application video. Well, they could do mapping 5 years ago. Now the Roomba does mapping. Few years later, this is a cleaning robot, and the company doing extremely well. They raised a 23 million Series B with one of our co-panelists later, actually. More interestingly, as a robot, this is it operating in Changi Airport in Singapore. What's remarkable about it is that nobody cares. People walk around it, don't look at it. Like, oh yeah, what, that's a big Roomba. Third bias is the makeup bias. Sometimes investors look at a prototype that's really polished and they feel that it's ready and they're like, oh, can I buy it? And when do you start selling? And then the startup would say, well, it might take another year or two before it comes out of the factory line. And that's exactly what happened to Neura. That's the early prototype, May 2016. That's the one they shipped, January 2018. And that's reasonably fast, actually. But you can see it looks almost the same. So if you try to invest on this, you don't, unless you talk to the team, you don't know how much they de-risk the manufacturing and how much they have a good understanding of it. If they do, they might be actually very close to that. And investing just before is actually a great spot. And that's generally when they struggle. So risk and milestones, I think the time is really short, so I'll have to accelerate here. But the risk, tech, market, founders, timing, kind of classic for every startup. The question with deep tech is, do you need a PhD in everything to be able to invest in different sectors? I would say if you work with experts, you generally don't. And do patents matter? Sometimes yes, generally not, because it's all about know-how and software these days. And how to avoid the next Theranos. So we're going to talk quickly about this. This is the type of due diligence we do when we look at the startups. If there's a patent, we try to check the substance of the key patent. We look at the prototype, see if it's doing the core of what it's supposed to do. We try to understand if it's manufacturable. We have a pretty good understanding of that, being in Shenzhen for about 6 years now. Have they validated the price point with customers to understand the bill of material, the operations cost, and all this helps a lot. Then determine the next milestone for funding, clarify the insights for the end users. So those slides will be available, by the way, so if you don't, like that, save you some space on your phone. Is the team using the right tech? What would Google do is a question, yet not always a question, because Google tries a lot of things and succeeds at very few. So it's not necessarily a big problem. Actually, it could be bias of the tech later. And then the skills needed, you have everything required in the team. Market risks, pre-product validation is really challenging because you don't have yet the technology and the product. How do you validate a market? There are ways to do that using customer development, going to talk to potential customers and really try to understand the type of solutions they use now and whether you could be a good replacement. You have to be aware of false positives and focus on price, demand, and things like that. So there's methodologies being developed using business model canvas, talking to a lot of customers, doing some kind of agile research. A number of organizations are pretty good at it. In the US, iCore is doing quite well. Entrepreneur First has a number of branches. We actually have a partnership with them, based in the UK and other locations, and more recently in France and EU. Deep Tech Founders also doing things like that. Founders risk, that's probably the highest risk at the early stage, particularly because it's difficult to assess if they're first-time founders. Some of the major risks, they can't execute, can't get along, have severe Asperger, Silicon Valley burn rates, never ship. There's lots of problems. We've seen everything. 250 deals in hardware. So statistically, the most dangerous ones are probably the team that cannot execute, artists, as in have their vision of what they want to do and don't care about the business viability, and the maker addiction, which is basically keep building and building and building and building so that it's perfect but never shipping. Other challenge with scientists as founders is can they transition to being inventors, to engineers, to entrepreneurs and managers? It's not always easy, it's not always their skill set, it's not always their inclination. Sometimes they're better off being the CSO in the company. Sometimes the company shouldn't be a company and should be doing licensing of the tech to some other company. There's many different formats. Timing, too early is not great, because then you raise first seed, maybe you bridge a second, and then if you're still like far away from the market, then you struggle. Sometimes it works, like Magic Leap from 2011, just shipped like a few months ago, raised $2 billion until they shipped. Okay, worked for them. I think it doesn't work for most startups. I'm going to skip this example, I think it's short on time. I mentioned we have a number of resources, so we try to facilitate the first steps of prototyping through our resources in-house and experts, and the fact that we're in the middle of the world's biggest electronics market. Compressing timeframes. I'm going to skip that because of time. So really the learning here is that there are funding gaps, but not every early stage startup is built equal, and some of them might be a lot closer to a viable product than they look like. If you have this right filter when you look at them and you ask the right questions, then you can see that and seize those opportunities. Due diligence, things that don't work at early stage with deep tech is probably a monthly run rate, CAC, LTV, page views, FDA. If a company has already cleared FDA, they probably don't need early stage funding. They're going to get acquired by Medtronics. Then patents, sometimes is interesting, sometimes not so much, because very often it's all about the software. On the small startup can defend a patent anyway, generally. The question that actually matters, what's your total addressable market, properly identified? Who pays? In the case of medical devices, sometimes there's really good systems with either insurance or the healthcare system that could work. What's the key differentiator? What's a 10x thing you do much better than others, and ideally better than that other company that just raised? That's all I have for the introduction, already a little bit over time. We'll have more time to discuss and get your feedback during the panel after the break. Now I'm going to introduce a few of our portfolio companies that actually develop deep tech, and they will share a bit about their journey and about the technology they're building. So I'll start with the first company called PushMe. Put some hashtags, so e-scooters. Anybody ride an e-scooter here? Very few. Is it legal in London?
Not really. Private land only.
Private land only. Because I was looking for like a kickboard, and there was one jump bike, one. So probably piloting. And I was looking for a Lime kickboard, and they have Lime bicycles here. Yeah. Very strange. That's me in Paris. That's my phone. All the apps for mobility. Now that's pictures I took. That's jump. But not sure. There's probably wind. Don't remember that guy. Dot maybe. Voy. So there's a bunch of bolt. Okay. So there's like a lot. Okay. Well, French down more wild. Yes. And so those guys are actually developing a technology that help operators with that. So maybe I'll invite our speaker to join me here. And tell us about tell us about your machine. So you have a kind of charging station, and I think you have a little video here, right?
Yeah.
So George is the co-founder of PushMe. So tell us what's going on here.
Yeah, so what we do is we build and deploy energy stations for shared scooters, and the idea is that we place the battery swap stations inside centrally located convenience stores, and then we enable the users of the shared scooter service to effectively instantly recharge the vehicle in exchange for ride credits. Now,
so people get paid to recharge?
Yeah, so they get paid $1.
Okay,
Instead
of much more, they take the whole thing home to charge it, right?
Exactly. So
but it's much more flexible.
Yeah. The current model is to employ gig economy workers, and they pay them around $8.50 to $10 to take scooters inside their own homes, charge them every night. Each scooter needs to be recharged on a daily basis. The other method is to deploy their own operations teams, pick up scooters in vans, take them to a warehouse. So with our concept, you can reduce your recharge cost by about 80%. by paying your users $1 in credit.
So like you're trying to sell picks and shovels to all the kickboard operators. So it looks like you're just a battery charger. So tell us what's the tech about it.
Yeah. So we use machine learning to optimize battery lifetime. And sort of the general principle behind that is if you want to optimize the lifetime of the battery, you need to know its history, you need to know its temperature, a bunch of other data, and then you need to charge at the acceptable rate of current. So what we do is we collect data on the battery, the station is cloud connected, we push that data to the cloud, and then we have a software service that determines the optimal rate of charge for each battery. So what's the quickest we can charge it without completely sort of messing it up. And the overall effect is we can double the lifetime of the battery, which is key for the shared use case, because people look at sort of the cost of using that battery on a per unit basis. So we have that cost of use.
Okay, so basically the kickboard will last longer, twice as long, the kickboard battery, and then the charging will also cost them a lot less because they can use those stations.
Yeah, 100%.
On more time. And so I know one of you in the team is ex-Deliveroo, and you started looking initially with e-bikes. So what happened?
Yeah.
Why not e-bikes?
When we started in 2017, we were initially building this for delivery fleets. So working with Deliveroo, co-founders ex-Deliveroo, so we knew a sort of a small market existed, we just didn't realize how small. And sort of when we went out to launch, we realized we couldn't really scale a big business into delivery careers. And we decided to pivot into micromobility. And got lucky, because that was right before sort of European shared scooters boomed. And we ended up having the most advanced, tech-enabled recharging solution in the market.
So now they're all calling you?
Yeah, yes. So within a matter of, so after the pivot, which happened sort of 3 months, sort of we raised about $1 million to date in pre-seed and seed, and 3 months after we raised, we made the pivot, which was fairly brave, worked out. Within about 3 months, we secured demos with the majority of the big operators. And everyone's pretty much trying to reduce and optimize unit economics. One way to do it is you pretty much offset the operational cost of doing recharging and rebalancing onto the users. They're already doing rebalancing, and now the next step, everyone sees this as the future, is to use tech to get users to do the recharge for you. So this is in effect what we'll do.
Excellent. So now you're raising, or you're going to be raising funding soon, right?
Yeah. So now the situation's changed. We're raising $3 million, looking to close by the end of the summer, and that's going to get us to 6,000 vehicles on the road and 4 markets launched in Europe.
Very nice. Thank you very much.
Sure.
So I wanted to have this example because not only it's timely with all the scooters booming everywhere, but also because it looks kind of simple, but behind it, when you understand they kind of built some kind of Fitbit technology for batteries, you start to see there's actually complexity involved, and it's not so easy to replicate. Next company is a company called Nitrates. I guess some of you know of 3D printing. This is kind of a 3D printing a bit special that has plans to also become a distributed network of 3D printers. And this is the machine that kickstarted some time ago. It's basically a 3D printer for knitwear. You can see it here. So if you're a modern gentleman who's like also moonlights as a cross-dressing comedian, like the gender, you might want to update your outfit. That's one way to get it really custom. Or if, in addition to being a comedian, you also run for charity, you might make your own knitted shoes. And to tell us more about the technology and the company, I'll call Triam to join you.
Thanks, Ben.
So, tell us more about what's going on here.
So basically, the way it works is you will be designing on the cloud, and then this will be put into an SD card, and the SD card gets here, and the machine will just knit it. So you can have all sorts of knitted designs. It's pretty much translating the idea of 3D printing, but into fabric.
So how did you create that machine?
The idea started originally with Gerard Rubio, who's a co-founder. He had been working with 3D systems, MakerBot, and had experience with 3D printing. And he decided to go back to school after that and studied media design, and was in a school where there were a lot of students doing sort of fashion work, and it's mostly really repetitive tasks where what you're learning in terms of design is not being applied. It's sort of just like a side thing. So coming from 3D printing, he thought, oh, what if like we bring in this same kind of idea and ethos into fashion? And he did some sort of research. He found out that at an industrial level, you can find quite advanced technologies, but there's no sort of
They're like giant machines.
Yeah,
Right?
giant 100K machines, but there's no sort of democratized means of production in the fashion industry, and so that's kind of what he aimed for. And
So is it to sell to consumers? How much is the machine at the moment?
the machine now is selling for 10K.
So 10 times
so
cheaper.
okay, so yes.
So you
10
can print
times
all these
cheaper.
things.
And you can make all sorts of designs that basically traditionally would have taken you, a jumper would take you a month if you're doing it alone. So it's basically, yeah, democratizing the means of production, bringing back fashion production, and helping people to start their own businesses.
And so, how have you financed yourself so far?
Yeah, so the project made it into Vimeo, as it went viral, opened it, the open source project. And then Duncan Turner from Hags got in touch with us, and he was really interested in design, kind of pushed that idea forward. When Terra started, he didn't have kind of a commercial goal, but that kind of evolved clearly. And so, yeah, we went to Hags. We kind of tried to build the whole thing ourselves, which was an interesting experience. And then kind of did a Kickstarter, raised funds, and
Over
then,
$500,000, yeah?
Yeah, over $500,000.
In sales, essentially.
Yeah, all sales. So 100K as
That's
funding,
awesome.
and then everything else have been pre-ordered. So we've self-funded till now.
Are you shipping?
We're going to be shipping late this summer, and we've had sales of 1.5 million.
Pre-sales.
Pre-sales.
And you already have machines working also?
Yeah, they're all
printing sort of
working.
things.
We're based in Makerversity. The machine is accessible. People come learn how to use it. Yeah, so any one of you can.
So entirely self-funded so far?
Yeah.
Pretty much.
Yeah, pretty much.
Wow. And are you raising funding in the near
We will
future?
be at the end. We really wanted to get to a place where we were shipping to feel comfortable with our product. So we will start fundraising at the end of this summer.
Okay. Are you looking for what kind of amount?
We aim to raise 5 million. There's a lot of work to be done in the
$5 million.
$5 million, yeah, mostly for software development. There's a lot of work to be done on developing.
Because you want to build a network, the community,
Yeah,
the ability to download patterns.
Yeah, so there's this kind of two levels. There's designing on the cloud, so something similar to Adobe Creative Cloud, and then there's also having a platform where people can exchange digital designs, which is more like of a Shapeways concept, and also
Like Shapeways for
connecting-
fashion.
Correct, Shapeways for fashion.
Okay, excellent.
Thank you.
Thank you.
Cheers.
Remember, winter is coming, right? Next one is a little bit unusual company because it's at the intersection of hardware, software, machine learning, and biotech. I'll probably invite Federico to tell us more about it because I wouldn't be able to do it as well as he does. So tell us a bit about what's going on here.
So, long story short, this is the PC for biology, and this is the desktop tool for the 21st century lab. And what you see here is that we're manipulating liquids, but it's not just that. This is the chip you see here. And what we do is we take a huge lab, big like this room, and we shrink it down here. So we integrate the movement of the droplets, the manipulation of the liquids, the sensors, the
So it's for
analytics.
liquid handling. Instead
Exactly.
of pipette by hand,
Yeah.
you automate it with this kind of
Exactly.
microfluidic
And
thing.
that's what you do on a daily basis in R&D labs, but not just that, also going to diagnostics. That's what you do if you want to, transform some atoms into bits, right? Going from the physical world to the digital world, you have to probe it.
So how many lab tech are going to be out of a job because of your thing?
Approximately,
Or are they going to be able to do more?
Yeah, they will
More
be able to
things.
do more, but most likely you will need less lab techs, and our estimation is 80% less basically labor work. And at the same time, we reduce by 100 times the cost of the overall research because it's miniaturized.
Because you don't need as much reagents.
Exactly.
It goes faster.
This is really, really small, so this is magnified, of course, and it's really miniaturized, so we take something that was bigger and we shrink it down in size, make it cheaper, faster, and connect it with analytics. That allows you also to improve upon like what you're doing.
So you have this box in which you put your microfluidic solution on this kind of a electrostatic movement of liquid.
Yeah, so this is called the digital microfluidics, and the device you see there, it's our working prototype. Actually, this is the early access program, so we ship this to research labs, companies actually, and bigger companies. And what this does, it fits on your desk, or actually on your bench. You see there's a computer, this is the bench of a scientist, let's say, and then they just start straight away. In 10 minutes, we saw that they're able to learn and start,
Wow.
and that's the kind of user experience you want. You want to have them doing the same thing they were doing before, but now with our device.
And just if you're not familiar with microfluidics, because some of you maybe do that on a daily basis, but some might not. So here you have an example. So you get two different liquids, and you would mix them to get different concentrations or to get different reactions to be able to observe results on the plate.
Yeah, so I'll give you an example, like, you have the blood and you want to measure glucose, so you have to mix A and B together and then mix them up enough and then shine a light and see what's the color out of it. So a person can do this like, one per time,
Yeah.
so this can do like hundreds at the same time.
And very fast.
And then get all the information out. This is your reproducibility.
And you can analyze with computer vision or something.
Exactly. So we have computer visions. We have very different sensors that allow you to basically get all the data out.
Wow.
It's actually
What's interesting that a few years before, we invested in a company called OpenTrons that does automated pipetting. They have a robot that you put on desktop that does the pipetting with these type of things. And they're doing very, very well. But this looks like, so you're not targeting the same thing because you're more about like more DNA research and these type of things. But it's interesting to see the shrinking of the tools and the digital aspects of it.
Indeed, like they work really well where they have a lot of samples, and basically what they do is they need to move a lot of liquids from one plate to another one, but you still have to go to the instruments that are the other component of the lab. With our tool, you don't need this anymore. Mm-hmm. Everything happens in one place. So from the preparation to the analysis, to eventually like the message, the signal goes out. This is fully IoT. And eventually, what you really want as a researcher, as a scientist, is not the sample, it's the data. Is it good? Is it bad?
Design the experiments and get the insights. You have a question?
Just wondering, can you use this in food manufacturing and
Actually, we do have a project around it. So for example, like in food, there's a lot of at-line testing, and this is why